Alright guys, we're going to look at Unit 7.1. Talks about the area of rectangles and parallelograms. So, the formulas are on the front page. The formula right here. Okay, it's the same for both of them. And you're basically multiplying the base times the height. So, we'll look at a couple example problems. But if you look at the three examples I have in the center of the screen, for each one of them, you're looking for a base and a height, and those two measurements should be perpendicular. So there should be a lot of these little right angle triangles. So like in this case, the one in the middle would just be 8 times 4. The area would be 32 centimeters squared. So we're going to go to the back of this page right now. So flip it over to the next page, and we're going to look at these 4 questions. Now the first one's pretty straightforward. You got a parallelogram, okay? 8's the base, 10 is that dashed line, 10's the height. So this is just going to be 8 times 10, which would be 80, in this case centimeters squared. Now 2 and 4 are a little different because, well, we have a base of 11, but we don't have the height. So I'm going to mark that with X. So we need to figure out what that height is first. And then for 4, I'm going to mark a right angle in here. So we got the base of 5, but we don't have the height again. Now we have 13, which is a diagonal line, but that's not the height. Height's got to be vertical. And the next one we're going to look at is 3. So with 3, it's not a rectangle, it's not a parallelogram, but it is a collection. And you can break this picture apart into separate rectangles. So I'm going to label all the sides that I can for the measurements. So I know that this line mark is 6, so that means this is 6. I can also come up with 6 for this side, because 6 and 6 would give me that 12. And then I also know that because this part over here is 6, and this whole thing is 8, I know that this part right here is going to be 2, because 6 and 2 would give me that 8. So for question 3, what I want to do is I want to multiply the base and height for each rectangle. So for this top part, it's 12 times 6, which would be 72. And then 6 times 2, which is 12. So the total area for those two rectangles is going to be 84 centimeters squared. Now for 2, what I want to do is, because there's an angle measurement of 45, I want to use either sine, cosine, or tangent. So the first thing I'm going to do is label my sides. So I know I have the hypotenuse here, because my right angle is in the corner. X is my opposite side. And then down here would be my adjacent. So I have 45 degrees and I have the opposite and hypotenuse, so I want to use the sine formula. So I'm going to do sine of 45 equals x over 5 radical 2. Now for this one, you set it over 1, and you cross multiply, so you got to multiply sine of 45 and 5 radical 2, and that ends up being, the height ends up being 5 for an answer. So we end up for 2 getting 55 centimeters squared. Now going over to 4, we have to use Pythagorean theorem, which again is on the sideboard if you need it, but write it down on your paper because you're going to use it a couple times for some of the questions. So for this one, we have 5 for a base. We don't know the height, but if we plug this in Pythagorean theorem, it's going to be 5 squared plus x squared equals 13 squared. So you want to square both sides. 25 and 169 you get for those numbers. Subtract 25 on both sides, and you get x squared is 144. And then when you take the square root of 144, you get 12. So this one becomes 60 centimeters squared, 5 times 12. Now the last part we're going to do together is the bottom part. It looks like a grid on it. It says to shear the parallelogram to get its area. And shear is another word for cut. So what we're going to do is cut out triangles and then replace them in different parts to make squares. So for example, on the first one, I'm going to cut out this triangle right here. So I'm going to take that triangle and I'm going to move it and place it there. And then I'm going to do the same thing with another triangle. I'm going to take this triangle. That's not complete. It's not squares. I'm going to cut that out, and I'm going to stick it right here. So I'm going to count each of these squares to get my area. So my area ends up being 5. Now there's no measurement, so I'm just going to leave it as 5. And then over on the fifth one, same thing. I'm looking for any triangles that I can kind of move around. So I'm going to cut this triangle out. I'll place it here, make a square out of it. I'm going to cut this triangle out, replace it here, and sometimes you can replace it more than one spot. And I'm going to cut this triangle out and replace it here. So that leaves me with 1, 2, 3, 4 for the area. So if you need any help with anything besides the notes, just make sure you get my attention in class right now. Okay, and good luck.